So you'll remember that we talked about how the sun, the solar energy, is the ultimate source of most of the energy that is used by ecosystems on the planet. So sun powers photosynthesis. It also powers the hydrological cycle, the water cycle, as the sun heats up the oceans and water evaporates and then moves into clouds. And so solar energy is amazing, and there is a ton of solar energy available on our planet. So why don't we use solar energy? Well, they talk about the difference between the quantity versus the quality paradox. So quantity versus quality paradox. And so this is the idea that there is a lot of solar energy that we could potentially use, but it is a poor quality because it is very diffuse. It is happening all over the planet. And so it's not concentrated forms of energy. So if you think about fossil fuels, like once we find a concentrated oil reserve, we could just go in there and pump out the oil, and it's very dense, right? And it is high quality. So it is oil is very high quality because we can take that oil and burn it and release lots of energy that powers everything that we do, right? It powers all of our buildings, that the source of energy. And so it's much difficult to use solar energy. And so there are a variety of ways that we could capture light energy, but storing it and then also distributing it becomes an issue, and it becomes expensive. But again, there is no guarantee that if we moved to sources of solar energy, that our quality of life is going to actually decrease. And it obviously solar energy is preferred because it does not release greenhouse gases. And so it's not going to cause these dramatic, catastrophic shifts in our climate that we are going to see definitely, and might already be seeing if we continue to burn the fossil fuels. So again, you have to talk about the real cost of using a resource. And so the real cost of using oil and coal, for example, and natural gas, which is also a form of fossil fuel, is not borne out by its cost to the consumer or the people that are using it. So it should be more costly because of what it is doing to the planet, but it's not. So when we talk about solar energy, we could talk about different ways that we could get the energy from the sun and turn it into something that we could use. And you probably have heard about passive solar design. And this would be where we design our buildings so that they, for example, in the Northern Hemisphere, there's south-facing windows so that you can get light energy warming up the inside of your house. And so this oftentimes involves also having a heat sink. So you might have like big, thick walls, or you might have tiles that are able to absorb that energy and then slowly release that energy out to the environment. So passive solar design is not turning it into electricity. It is simply using the light energy to, say, for example, heat our homes. Rather than burning oil in your furnaces or burning wood, you would use a passive solar design. So that is one way that you can use light energy. We could also heat up fluids. And so we can talk about what are called solar, so this is the first one, solar thermal collectors. And if you've ever had or been to an outdoor pool, this is a very useful example of that, where you might have a pool covering, right, that helps to heat up the pool. You might also have like the pool water going through a series of pipes that are being exposed to the sun. So this would be where you heat up liquids, and then that concentrated heat in the fluid can be used to warm up your swimming pool, but it could also be used to warm up buildings. It could be used to heat water. So for example, there was very popular when I was a kid, people were putting these on top of their roofs, and they were using them to heat up the water, their hot water. Instead of having an electrical hot water, they would use the movement of the water through the pipes that were exposed to the sun. And so this is an example of one type of technology that we could use to heat up water. We can also have what is called and this is from your textbook, what is called a solar power tower. So this is where we have an area that's getting lots of light. And so one of the problems with solar energy is that it is not distributed equally on our planet. So we have more solar energy hitting the equatorial regions of our planets compared to up near the poles. So we have more energy available there. So this would be like, say, for example, in a place that gets a lot of sunlight, but also doesn't have a lot of cloud cover. And so this would be where we have a field of mirrors that reflect the sunlight into a central receiver. And this transfers energy to fluid, and then the movement of the fluid is what generates the electricity. So this is one way that we could generate electricity, kind of related to that solar thermal collector, but on a big scale. So mirrors reflecting onto a tower, heating up the fluid, the movement of the fluid, then maybe it moves a turbine, it's mechanical energy turned into electrical energy, but then we have to somehow get that electrical energy stored in a battery or perhaps transferred out to where it is needed. So that becomes another technical issue. So when we talk about solar energy, you are probably, and the use of it through technology, you are probably thinking of what is called photovoltaic energy. So we have what are called photovoltaic cells, right? Or PV cells. And these are the solar collectors you see these days on houses. And so these actually take the light energy and convert it directly into electricity. This would be like what you have on your little calculator. Say, for example, if you have a photovoltaic calculator, that was a big deal when I was a kid, if you had actually one of those instead of one that ran on a battery, right? So, or you might have them on the lights that power in your yard, right? So during the day, they have this little collector that turns into electricity, powers a little battery, and then at night, it glows light. And so these are probably the most common way that we generate electricity using light energy. And it's very interesting because one of the ideas is that perhaps each household could become energy sufficient so that we could all have energy being put into maybe batteries. That's one option. If you want to put a solar energy system, is you could put a battery in your house, and that battery could supply energy to your appliances. That could be useful if you're off grid, but if you're on grid, right, that energy could go out to the grid. And so it could go out and be stored and be shared amongst places that need the energy. So perhaps you could generate additional energy that could be used, say, for example, in the summer, and then that could be shared out. And then you would then, in most likely situation during the winter, you would need more energy than you're actually generating. So there's a lot of interesting things going on with solar energy and the technology. So it's something to be excited about, and its potential is very interesting. Remember, there are other sources of renewable energy, that are ultimately powered by solar energy, including hydroelectric. So, not hydroelectric, wind powered turbines. So remember, the sun actually helps to create these wind currents, differences in gradients that allows the wind to move. And so that would be another source of renewable energy that we see around here would be those energy, the turbines, the windmills that are turning and generating electricity as they do so.